In this video I'm going to consider the Pythagorean trigonometric identities, which relate expressions of sine and cos and tan and their reciprocals to each other. So let's start off by just quickly reminding ourselves of the reciprocal trig ratios. There they are. Sec x is the reciprocal of cos, cosec is the reciprocal of sine, and cot is the reciprocal of tan. And an identity is a statement which is true for all values of the variable. So we've already come across the Pythagorean identity, which relates sine squared, I'll use A as the angle. So we've already come across that statement there. Sine squared A plus cos squared A is equal to 1. Now that's saying for any angle A, for any value A that you enter, that statement will always be true. Let's just be clear as we work with this that we understand what sine squared A means. So we say sine squared A, and by that we mean the square of the value of sine A. Alright, so just a little bit of quickhand, rather than writing the brackets every single time, we can just say sine squared A. And the reason that we need to write it that way rather than this way is because in that case it wouldn't be clear whether we meant the square of sine A or the sine of A squared. So in fact, if you see that expression, you can take it to mean square A first and then take the sine of that value. Alright, so over here we've got our initial Pythagorean identity. Our initial Pythagorean identity here, sine squared A plus cos squared A is equal to 1. Now I want you to think about what would happen if you took that expression and you went through and divided every term by, or basically we're dividing both sides by cos squared A. Okay, so we divide everything on both sides by cos squared A. Well, sine squared A over cos squared A, if I use my index laws, we write it over here, but I could say that's the same as sine A over cos A squared. So if I've got the quotient of two squares, I can make that the square of the quotient, and sine A over cos A is equal to tan A. So that's going to be the square of tan A. So our first term here will be tan squared A. When I divide cos squared A by itself, I'll just get 1. And over on the right hand side, 1 divided by cos squared A, I could write as, since 1 is equal to 1 squared, and 1 over cos A is sec A, so it's going to be the square of sec A. Right, so from that initial identity, if I divide everything by cos squared A, I get a second identity. Now if I went back through and did the same sort of process, but this time divide everything in the original identity by sine squared A, well, dividing sine squared A by itself would give me 1. Dividing cos squared A by sine squared A would be the square of cos A over sine A, and that's cot A, so that would be cot squared A, and 1 over sine squared A is cosec. So those three are considered the Pythagorean identities, which relate expressions of sine, cos and tan and their reciprocals. You don't need to remember any of these because they're on your formula sheet. What you'll see there is they're actually the first out of a whole stack of identities that we're going to be considering. So the Pythagorean identities there, don't need to remember them, don't even need to remember exactly how you get all of them, but we do need to be able to use them. And so that's what we'll sort of consider now. How can we use those identities? So let's consider maybe a few questions from the exercise that we'll be working on. So we're going into exercise 14A. And there are various sort of questions in here that might require us to use different ways of thinking about these identities. Let's go to question 4. And we're given the expression sec theta is equal to negative 17 on 8. And we're also told that theta lies in the domain between pi on 2 and pi. So hopefully you can appreciate that that statement there is saying, if we're sort of thinking unit circle, that's saying between 90 and 180, so it's in the second quadrant. Okay, and the second quadrant is where sine is positive and the other ratios are negative, aren't they? So obviously if sine is positive and cos is negative, then the reciprocal of cos, or sec theta, also has to be negative in that quadrant. Sec can be negative in that quadrant. It's also negative in quadrant 3, isn't it? Because sec is negative wherever cos is negative. So this helps us to know that not only is theta either in quadrant 2 or 3, but it's specifically in quadrant 2. Alright, the question's asking us to find the value of cos theta, sine theta, and tan theta. So we know that sec theta equals 1 over cos theta, so therefore negative 17 on 8 is equal to 1 over cos theta. So therefore cos theta is just going to be the reciprocal of that, isn't it? So negative 8 on 17, and as we said, if sec is negative, cos will be, and vice versa. The second part of the question is asking us to find the value of sine theta. So here we might choose to go, well, let's use our identity. I'll use theta instead of a. Sine squared theta plus cos squared theta is equal to 1. Therefore, sine squared theta plus the square of negative 8 on 17, because we worked out that's what cos was equal to, negative 8 on 17. So therefore sine squared theta is equal to 1 minus the square of 8 on 17. You might need your calculator there. What's that? 64. And if you grab your calculator and square 17, it's 289. So 289 minus 64 would be 225. And so when you take the square root of that, you would get plus or minus, well, what's that, 15 over 17, isn't it? So sine theta is either positive or negative 15 on 17, and that's where we'll need to use our knowledge here that since theta lies in quadrant 2 where sine is positive, we can say therefore sine theta is positive 15 on 17, since theta lies in that domain there. And finally tan theta, well, again, you could use your identity involving tan squared, so we could use this one here, tan squared theta plus 1 equals sec squared theta, because we were given sec theta. But since we've actually already worked out sine and cos, it's probably easier just to go tan theta is sine theta on cos theta. Sine theta was 15 over 17. Cos theta was negative 8 over 17, so that's going to be negative 15 on 8.